I know people, and you know people, and you know people that know people, and you might even be one of those people. That's right. If you're a person that's wanted to get started in 3D printing, well, this is the video for you. This is the absolute newbie. How do I do 3D printing? Because you might work with somebody that knows something about 3D printing. You might have a friend, you might have a family member, a neighbor that does something with 3D printing. And you're wondering, how do I do this? You know, is this too complicated for me? Is it too expensive? Do I have the skills to do it? You might be a woman thinking this is a guy's thing, or you might be a guy thinking this is a woman's thing. I know a woman down the street from me, and she was on the Prusa website, and she kind of has the open house, and I went there before I bought my Prusa Mini, and I got to see her stuff in action and all the little artistic things she's doing, and she was using a ZBrush, and I was like, wow. I had no idea what all this stuff was about, but my son had a 3D printer since he was 10 years old, and his bedroom was just full of plastic, and I says, what are you printing? A test pattern. And you know, Mr. Mechanical was printing all these test cubes and calibration cubes and measuring them with a caliper and making sure that everything was just spot on accurate. And I heard all the terminology, and it kind of went in one ear, out the other ear. I didn't really I didn't understand all the stuff I heard is what it was. So, to get started, I'm going to give you the big picture, the 50,000 foot view from step 1 to step 10. I think when you start a new project, it's always important to take the idea and do a dry run from step 1 to 10. Because you don't want to be making a book or a house or something, and then you realize, like, oh, I've been working, a year on step 1 and another year on step 2, and by the third year on step 3, guess what? I found out step 1 is all wrong. So you take something small from beginning to end, and you learn a lot by doing that. So I'm going to suggest a program called Wings 3D. It's 100% free. It's open source. Wings3d.com is the website. It's right up there. And you can go on the website and you can see some of the interesting things that people are doing with this stuff, all right? I mean, it's not AutoCAD. It's it's not a high-end modeler, but they say the poor workman blames his tools. So it's a subdivision modeler. It's open source and it's free, and it runs on your PC. I think, let's see, does it run on a Mac? Yeah, so it runs on Windows, Mac, and Linux. I'm going to show you the Windows version because that's what I have. So it'll run on anything you want. And we'll go from there. We'll take something very simple. Okay, and first we'll define the biggest thing with 3D is you got to understand that you're looking at three-dimensional objects on a two-dimensional flat screen monitor. Okay, so that's the hard part. You can go over here and you can insert. I did a right click and you can insert a cube, a cylinder, a sphere, tortoise, cone. Okay, so you can make a tortoise, and then there's ways to select and move by point, edge, face, or the whole object. Okay, so typically when you think of moving, there's three things that you typically do with geometry. You can move it, translate it back and forth, as they say. Okay, so you can move it left, right, up, down. You can move it in all three dimensions. Z in the printing world is up and down, and X and Y, or X is left and right, and Y is to and closer to you, further from you and closer. And that's one thing. So you can move it, you can scale it, you can make it bigger or smaller, okay? And you can rotate it. You can turn it on any axis. You can turn it on, you know, if you're turning it on the vertical axis, it's turning this way. If you're turning it along the x-axis, it's turning that way. And if you're turning it along the z-axis, it's like rotating around, like you're looking at the other sides of it. So it's easy to get lost in three-dimensional space, especially when you only get a 2D view. You'll see two objects and you think, oh, they're right on top of each other, you know, and then you look at them from a different angle and you find out there's this big wide gap because, you know, you're only seeing a two-dimensional view of it. And two eyes don't help you because the monitor, it's not a stereo view monitor where you can move your head and, you know, your brain can figure out small differential movement. So here we have this tortoise and we can move it. So we could free move it, but let's look at that later. So we can move it along X. Now, a long time ago, I think Maya and AutoCAD decided that the x-axis would be red, the y would be green. So red, green, and blue. So RGB colors, red, green, blue for X, Y, and Z. Very handy to know that. Okay, so we're going to take this and we're going to move it along X. So X is red. So no matter where I move my mouse, right, I can move this thing all over the place. It's only going to move up and down the X. And right down here, this status bar is very handy to tell you what's going on. Left means you select. Okay, so left is select. And M is the middle button. So that'll pick your start center. And the other thing you should know is that space bar is the deselect, not the escape key. You would think it would be the escape key. So if you're hitting the escape key and trying to do unselect things or bail out, it's the space bar. I don't know why, but it is. Okay, so, but the escape will clear the menu. So you can click on this and you can move this along any of these axes, right? One at a time. And you hit escape, nothing happens. You hit the space bar, boom. And you deselected it and it keeps it where it was. Now if you wanted to undo it, you can hit Control Z. It should put it back, but it doesn't seem to. Not sure why. Okay, so you can click on the object here. So these have shortcut keys. They have V for vertexes, the dots, E for the edge. So the V key, the E key, the F key for face, and then the B for the whole box or the whole object. All right. So we can click on this and we can move it free-handed. And so it'll move anywhere you want. And this is where you can get lost. It's better to move one axis at a time and understand where it's going. Okay, so we will do a right mouse click. So a right mouse click puts it back to where it was. It cancels the operation. So we move it along the Z, do a right mouse click, it puts it back where it was. So that's your right mouse click is like your cancel, your escape key. All right, if you want to delete an object, you can select the object and hit the delete key and it disappears. You want to make a new object, you hit the right mouse click and you can enter a cube. Okay, so there's a cube and now let's move an edge. So I can pick that edge. Okay, it's highlighted in red. I can right click and say move and I can just move it along the Z. So there, I'm moving that edge along the Z and it keeps the other faces and points connected to those points. Okay, so in the CAD world, whatever CAD program you're using, you have the high level here. This is stored as a cube. Let's, yeah, undo is not your best friend here. So let's take that. We're in the face mode, and we can hit M. Or I don't think we can hit M. But anyway, we can hit X, and that's moving that face along the X. Or we can hit move, and we can take that face and move it along the Y. Okay. The other nice thing, you can take this, and here's some like high level commands. You can inset this face. So it'll take that face and it'll like make an inset equally around it as how much you want. So you can make a little bit. You can select this face again and inset it again. And we'll go a little bit more. All right, so this is not really like, you're not specifying how much, it's kind of artistic. And it's just like what looks right and what feels good. So you can click this and you can move this. Now we want to move it along the blue line. So we got red, green, blue. We'll move it Z and we can move it up. You can see, you can move it down. You can move it through the bottom and we'll move it about there. Now the middle mouse button, when I click the middle mouse button and let it go, it'll rotate. So there you see what we got, right? And then the wheel of the middle mouse button will scale or move you closer to the camera. So the settings here, you can set your colors and things like that. You can set your camera. I'm not going to go into this because I'm just trying to get you to do simple things. What you want to do now to print this is export this as an STL file. Okay, so there's a lot of different exports. I assigned an F12 key to the stereo lithograph, STL. So let's talk about how this is stored internally, right? This face is stored as a point XYZ coordinate, has an X and a Y and a Z, and then this face shares that same X, Y, and Z as the same coordinate, so this connects from here to here to here to here and back, and that's a polygon. Okay, so that's a four-sided polygon. All right, this, let me move to the inside. That little floor, very hard to get where I want to go. But this is also a four-sided polygon, except it's not a square. And these are four-sided, so all these are saved as geometry with points, okay? And if you follow the points in a clockwise direction, the face has a normal side and a non-normal side. So this geometry here, this side is your normal side. The other side of this is not rendered. To save CPU time, the inside of this, or the other side of this red square is not rendered because that's the non-normal side. And every now and then you'll have your normals flipped, like if you take this thing and you turn it the wrong way or something like that. But you can take this here, let's if we want to deselect everything, we go to select, deselect. Should deselect everything. Okay, spacebar deselects everything. We'll click on that. We got the face selected. We're going to do a move. we move and we'll free move this. So we're moving this face, right? And you can see you can make some weird inside out geometry, but yeah. So we're gonna right click and cancel all that. And we're gonna click this again and we can rotate it on X. Okay, so that's rotating. So by doing this, this is the way you can build upon 3D objects. It takes a little bit of getting used to, but let's take this object and export it as a stereolithograph. And you can leave all these as defaults. Every unit over here is set to 1 inch. It's scaled for 25.4 millimeters per inch. And we'll call it my gizmo. I like to put version numbers on them because I might have my gizmo 101, 102, and hit that. Then you'll need a slicer. Okay? So first of all, what happened with all this STL stuff? The STL, instead of storing this as squares, it stored everything as triangles. The triangle is the smallest polygon you can make. And I will show you an STL file loaded with a different editor here. So this is ViaCAD PunchCAD. This is pretty much my go-to software. So if I load this STL file, you know, notice that this is not just a square, it's 2 triangles. This is a triangle. Everything in here is a triangle. Okay, it's split in half. So it's the minimum, smallest geometric shapes that you could have. And that's what the slicer wants. Now you're saying, now what does a slicer do? Okay, so a slicer, this is the Prusa slicer. We will open this up and we will load my gizmo that we saved, right? That's what we just drew. And that's what it looks like on the print bed. Okay, so again, red, X, Y, green, and blue is Z. Z is up. Okay, Z is up and down. Unlike in wings, right? When you're looking at this, Z would be, well, here Z is up and down. So you want to keep your orientation the same. They're not always the same. As you notice when you start off with a new project here. That Z is going this way and Y is going up. But in the Prusa slicer and most all 3D printer worlds, X across, Y back and forth, and Z up and down, because your head is Z movement as your head moves up. So it'll slice this thing up. And what it did here is it said there's stability issues because it's not going to be able to print this. But this is going to take 18 hours to print, all right? So because it's just so strange. And you're not going to print this because this is just going to fall down. You're going to need support. All right. So you can take this and scale this since they're all locked. You can make it 10% and it'll scale X, Y, and Z. All of them will go across 10%. And it'll give you, now you can print this little thing in 7 minutes, right? So it's really exponentially huge times. So we can go in here and we can make something simple. We can make a cube, all right, or we can make a cylinder. Let's make a cylinder. All right, we're selecting faces, so we can select a bunch of faces and we can pull these out and move them along X, which would be the red line. So You can push them in, you can pull them, and they're moving along the white and red line. Okay. Click on the right to get rid of that. Hit space to deselect everything. Click this face. Let's inset it just a little tiny bit. Let's click the face again and inset it again, because we'll need thickness of the wall. And then click this face and move it on the green line, which is red, green, down a little bit. I'm trying to guess about where it is. Okay. So you got a little pencil holder, a vase, or whatever. We'll save it as my first vase, which I had before, and overwrite it. And we'll export this as an STL. Keep the defaults. And we'll go with my first vase again. Overwrite the STL file. Go into the Prusa slicer. Get rid of everything. Import my first vase. And there it is. And at 100% of 2 inches by 2 inches by 2 inches, you're looking at 7 hours to print that. Now you can, most of your print time is on the Z height, so you can unlock these so these will not scale all together, and you can make this half the height. Okay, and it'll keep X and Y the same. And in that case, you're looking at 4 hours to print this. So that's pretty much how easy it is to design something in Wings 3D, convert it from a Wings file, export it into an STL, take the STL, move it into this Prusa or any type of slicer, whatever you want. There's a lot of free slicers out there. And then this is set up for PETG, okay? And you can set this infill because, as you see, this is what it would look like. Or let's move this over here. And as you scaled up and down the timeline, or go back and forth, you can see what the printhead would be doing. And this is Gcode. Now you're saying, now what is Gcode? So we went from a Wings 3D file to an STL file, and then we export Gcode. And Gcode is just very simple, dumb head movement. It tells the printer, go here, squirt some plastic, and keep squirting the plastic, and move here and here and here, and then move the table down or move the head up, whatever, however your printer works, and keep doing this. And it pulls in the plastic, it pushes out the plastic, it you know, extrudes and pulls it back in. And you set the temperature for your plastic. If your first layer does not stick to the bed, it's time to quit, because it's like building a house on the sand. The whole thing's just going to fall over, and you know, this is hot plastic, and the first part has to work. I usually use Elmer glue sticks, you know, those first grade kindergarten glue sticks, and smear it on the bed, and move this thing in the center where I want it, and export this to Gcode. So your vase.gcode, we'll open this up in Edit Plus, an editor. These are comments with semicolons. Yeah, don't be overwhelmed with this. And this is, every command starts with some kind of letter. So we're using the absolute coordinate system, and we got our intro line that goes across the bed, like right there. And then it says go from this X coordinate to this Y coordinate and extrude that much plastic, go from here to here to here, and it's just millions of movements. And so the slicer is all the magic. It takes the magic of 3D geometry and it turns it into that. Now, you can fill this with 10%, you can fill it like, well, 100%, but nobody does that. And you can determine how sturdy or how thick you want this plastic to be. So that's 90% fill, 15, 10, 15, 20% fill, and you can pick all sorts of different patterns. Triangles are your strongest pattern. So, I hope you like this. Give me a thumbs up, ring the bell, and tell me what kind of things you printed. Go ahead and try it. Print something small that takes 5-10 minutes, get the feel of it. It's separation 6, right? You got friends that got 3D printers. You got a library that probably has a 3D printer. You can take all this free software. You can take your Wings file, store it as an STL, take the STL, go into the slicer, store it as Gcode. You can make several different Gcodes with different plastic. You can slice it for PETG, you can slice it for TPU, you can slice it for ABS, PLA, PLA+, different temperatures, different plastics. Bring those Gcode files to your library and play around. Spend 5-10 minutes, get the feel. Go back, do it again. Rinse and repeat. And you'll learn something. Go from step 1, try the Wings, try the STL files, and export them and see what kind of time you're going to get out of them. Because when you go in here, it's going to tell you that it costs 16 cents. You put the cost of a roll of filament in there, and it's going to tell you how much filament you use in grams and inches, how much it costs, and how long it takes to print. And that is the steps from beginning to end. Now, is Wings 3D a program that you're going to use if you're a mechanical engineer or an artist or something like that? Is it an AutoCAD? Is it a ZBrush? No, of course not. I mean, several of those programs are $100 a year to thousands of dollars a year, subscription services only. There's web-based ones, but I figure, you don't want a web-based one because you got to pay for that. You want something that you can download on your PC, take your sweet time to learn for free. And so this will do it for you, and it's what you get used to. Other programs that I use are IntelliCAD 11.1, which is about $250. And the other thing I use is PunchCAD ViaCAD version 12 I have. It's not the latest, but that's about $200, and that's pretty much my go-to for making things because it's just easy. It makes a lot of things easy. This gives you the concept of, vectors, that you can move a vector around. You can take those points, move them around. You can, oops. Yeah, I wish we could undo. But that's probably one of the downsides. So you can click on, any number of vectors, move them, and it'll take just those highlighted vectors and move it around. So give me a thumbs up, give me a like, and I hope you subscribe. And thank you for all the people that do subscribe.